right, good afternoon.
Afternoon.
How's everyone doing today?
Not too bad. How about yourself?
Doing okay.
I do have a quick question if you got a quick second.
We got 2 hours of quick seconds. Go for it.
Alright. Well, this is pertaining to my SLP. Do you have any experience with Unity at all?
Very little.
Well, I'm having an issue. I have several levels of my game built at this point,
Mm-hmm.
and some of the levels are quite large, and it's causing a little bit of lag on basically the whole thing. So we'll load into it, and like the camera lags around, and I'm trying to fix it, but there's not really a lot of documentation on it. I've tried shutting down the rendering distance to about 100 feet.
Mm-hmm.
It kind of makes it look a little weird, but also, it kind of takes away from the game a little bit.
Right.
I'm not really seeing the level. Do you know, have you ever heard of that, or anything I should look into?
It doesn't sound surprising, right? I mean, every machine's going to have a limit to how much it can process and render. And I think it depends, on your CPU, your operating system, your graphics card, very particularly. And I'm not up on any of the specs of any of those things. I haven't spec'd out hardware in years.
We'll
But
just say that mine is probably the best computer
okay,
out there right now.
cool.
It's still about $4,000 building it, and it's got the best of everything.
Okay.
I don't think the computer's the problem. I think it's a Unity thing. That's why I was kind of curious if you've ever heard of someone having a problem in like maybe a different, or like something to look into, because I can't find any documentation on it. Nobody seems to have any issues.
My two suggestions would be, one, start checking some forums, right? Unity forums or Stack Overflow probably has a Unity area, and you'll find lots of people who have probably bumped into this in different situations, but you may find one that applies. My other thinking is that maybe, since you have a very high-powered machine, a lot of software is sort of preset for lower-powered machines. And there may be things you can unlock, like, use certain kinds of hardware acceleration or things like that, that just may not be turned on to start with. So I would dig into that also.
Yeah, okay, see, that's why I asked those questions.
Okay. Well, I can make stuff up all day, so.
Collision is expensive. Make sure you're not doing anything complex with it.
Okay, yeah, I'll look into that.
Cool.
Thank you, guys.
Yeah. All right, other questions? My plan for today is to talk about ODP 301, which was already turned in. To run through ODP 302, make sure people are square on that. Look for questions on PA 1B. And then talk a little bit about strings, statics, and then after the break, probably talk about creating a linked list class by ourselves from hand and kind of building it up from scratch as another example of, creating some classes and using them inside other classes to do something that we're already familiar with, such as, making a linked list implementation by taking nodes and linking them together and so on. So that's kind of my general game plan for today. And probably to watch some hail in an hour, because it seems to hail every afternoon now.
Yesterday was pretty bad for like 2 hours.
It hailed like, I don't know, 6 or 7 different times here, and then it would stop in between. It's the case sometimes where we get sunny in between, and then all of a sudden it would just be like, these weird giant things falling from the sky. But we're so used to, like, global pandemic and all of this stuff that I think most of us are just like, it's hailing in April. Okay.
Meh.
Whatever. Yeah, and frogs falling. All right. So let's look at ODP 301 just to kind of touch base on that. I'm moving my setup around here, so. So 301 was creating this my class, which had a constructor that would take an integer, and that integer value gets stored in a variable called x. And then if you want to access that variable, you can say, object name dot x. So it's a pretty simple class definition. It's a constructor that saves the argument to the constructor in a variable named x, and that variable is public. So it doesn't have to be anything more than this. So class my class, there's the property we're going to save things in. There's a constructor. It takes an argument, sets x equal to that, and that's all you need. And that should have assessed her 10 out of 10. So so things get more interesting with 302. And 302, we get into the idea that we want our x to be a private variable, so that you can't access mc.x from outside of the myClass class. And so in this case, you're going to create an accessor and a mutator, an accessor called getX, which returns the value of x, and a mutator called setX, which takes an integer and sets x equal to that. And so now, same test main program, if I want to see the value of x in this object called MC, I say mc.getX. And if I want to change x to 23, I say mc.setx23. And then if I do getX, that should return 23. So this is the test program. These are the two additions to the myClass class. And then once you've got that working and your test program looks good, go ahead and compile your myClass and assess it using this. And I haven't looked today. I looked yesterday, and people were mostly getting 10 out of 10s after a few tries. Anybody got questions about this ODP? All right. Any questions about PA1? The new part we went over on Tuesday, it was doing the try-catch block to handle parsing of integers and respond gracefully if something goes wrong.
Probably gonna do a quick final cleaning pass of it now that I know a few more tricks.
Okay. And remember, there's a sample code on the server that you can compare against, and as long as you do what that does, you're good to go.
I turned it in last week before you gave me the advice on not using ternaries, and you can make it return a boolean for is empty on both of them.
Okay.
Is the size equal to 0, true or false?
Right. Cool. So I'll get these graded over the weekend, and I'll post feedback. Just to let you know, when I graded PA1A and when I grade this one, I do a few things. I'll pull your tar file into a separate directory. I'll untar it. I'll compile the .java files. I'll run your main class, and I'll go through a series of tests. Right, I'll start in stack mode, I'll put a few things in, I'll go to queue mode, put a few things in, I'll look at the stack, look at the queue, remove a few things, look at the stack, look at the queue, put some things back in, make sure they're not interfering with each other, and then I'll pop everything off the stack, look at the stack and queue, pull everything from the queue, look at the stack and queue, and then put in a few things from the point where they've been emptied. And it's a pretty straightforward set of operations. There really aren't that many things you can do. So testing it, you can probably figure out a battery of test cases yourself to see if you're doing the right thing. And then I go into your code, and I'm going to look to see that you actually broke things up into those separate classes, and see how you're doing the toString method, and make sure you're not printing from toString and stuff like that. So I don't use any kind of automated grading for most of these larger programming assignments. I do for the ODPs, obviously, but these I'll definitely go in and look at your code in varying amounts of detail.
I got a quick question about the two-string.
Yeah.
For both of mine, when I did a return and the stack or queue was empty, it didn't return anything. It would just print nothing. It would just do top stack from my main program, and then blank. So I had it return the stack, or if it was empty, I just had it return square brackets, and that way, when you print it from the main program, it just shows top stack pointing to empty square brackets.
Perfect.
Okay, I just
Yeah.
want to make sure that's okay and I wasn't doing something wrong.
No, so you can try the sample program. That should be exactly what that's doing. So if the queue's empty, it says head bracket bracket tail. If the stack's empty, it says TOS arrow bracket bracket.
Okay, perfect.
All right, hold on one second. I got a Zoom issue.
You guys all having a good day?
So far, so good.
Let's go. Yeah, until my game started last week.
Been trying to make this RTS controller in Godot, and it's kind of hard because I need to do some ray casting.
Well,
Yeah,
that sounds
I think I'm
fun.
gonna have to do that for my it's a third person camera, and I'm having an issue with my trees blocking the camera between the player and the camera. And so I think
Speaking of
ray
camera
casting.
collision,
Mm-hmm.
you should look into camera collision too.
Okay.
So if it collides with something in the actual game, well, it can move back and forth accordingly.
Yeah, I have it set up, and it pretty much, if it collides with anything, it moves out of the way. So, like, it won't get stuck on a tree or anything like that. It'll move the camera, but it's still, if a tree is between me and the player, then it still will show the tree. So I need to, like, somehow render it transparent if it is between that, like, cast a ray between the camera and the player, you know?
All right, I'm back. So let's talk about comparing strings. And this is in the realm of this idea that pretty much everything in Java is an object, and there's a few exceptions to that. So the keyword int lowercase declares what we call a primitive, right? If we say int I equals 5, we're not creating an integer object, right? We're making a primitive int. It's like a C program integer. It's just a little thing that holds, 32 bits. Whereas there is a whole class called integer, uppercase I, which is a class like a string, like a linked list, like a scanner, all that other stuff. So when we have primitives like, little int, little double, little car, those are not objects, but pretty much everything else is an object, which means it comes from something that's a class. And strings are definitely fall in that category. Strings are objects, right? So let's play with these a little.
I have to wonder if the string compare method checks the hash codes in object.
That would be a good thing to do. Sort of do a quick false if things aren't equal. And then do the more detailed, expensive character by character check. That would be a good thing for it to do. So let's play with our command line arguments again. So I'll do this in steps. So here's our first version of this. We're just going to print out the value of arg0. It's going to be one of those days. Alright, now if I don't put an argument on here, I blow up, right? Why? Because I didn't listen to myself when I said 100 times in 224, don't use arg0 until you know that arg0 exists. Well, if you ignore that, this is what potentially happens. If you don't have an argument, and I try to do anything with args bracket 0, I will get an error. This is like trying to use argv bracket 0 if I haven't checked argc yet. So let's just let me sleep at night, and let's say args.length is not equal to 1. And let's just print a usage message. Alright, so now we're being law-abiding Java programmers. So if I say Java main, it'll say, say Java main followed by an argument. Alright, so if I say Java main haha, it tells me arg0 is haha. All right, so let's do some comparisons, and let's see if this argument is hello. And we know that the right way to do this is to use the equals method. And so if arg0 equals hello, I'll print a message which said you said hello, and I'm putting hello inside quotation marks just because I can, and to illustrate that if I want to print a quotation mark inside a string, I just escape it with a backslash. That's standard Linux type stuff. If I didn't have this, if I said you said quote hello, this quote would end the string that started here, and this would give me a syntax error. So backslash quote says, hey, this is not ending my string, this is just a character. This is just ASCII character 34. So is this. This is the quotation mark that matches this one. So that's something you'll see people do. So compile this, run it, and it says haha. If I run it with an argument of hello, it tells me you said hello. Alright, so far so good, right? This is how we compare strings using equals. So let's break this. Right? Let's try and use equal sign. And what you'll see really clearly is that this does not do the same thing as dot equals. Right? arg0 definitely is hello, but seeing if that's equal to hello came back false. And that's one of those bugs that will possibly take a long time to discover. Because, what do? You put in print messages, you print the value of this, and you say, hey, it's equal to hello. Why is it not executing this? So, and we learned this in C, right? You can't use equal to compare strings. In fact, in Java, you can't use equal to compare any kinds of objects, but you can use it to compare primitives. So if I and j are both lowercase ints, you can compare them with equal equal if I equal j, and so on. But for objects, we got to do other stuff. All right, but let me show you the more horrifying part of this. Right? If quote hell plus quote o equals quote hello, that turns out to be true. Why does that turn out to be true? I mean, certainly this is the string HELLO, this is the string HELLO, but for some reason in this case the equal equal is working correctly. And the reason that is because, you know, when you have a string like quote HELLO, the compiler is creating an object of type string whose value, right, whose contents is this 5-character succession HELLO. When the compiler sees quote HELL plus quote O, at compile time it concatenates those two strings because it knows the value of this string and this string. It concatenates them and it sees that this is a string containing the letters HELLO. It's already created an object for this HELLO, and so this simply refers to that same object. And so in this case, these two strings are going to be equal with double equal because they are the exact same object. They're effectively stored at the same location in memory, which is how double equal works on pointers in C. And so if we stumble across things like this, we can begin to believe that double equal sign will work. And sometimes, you know, if we put this in our code with double equal sign comparing strings, it will work, but for the wrong reason, for a different reason from what we think. And then if we try to do something like this, we'll suddenly find that, hey, my code's not working now, and we've already decided this is working fine, and now we're on a wild goose chase. Someone said this language is really bare bones compared to C#. I like to think that Java is pretty bare bones. You know, this is why C works, because it doesn't do a whole lot for you. It's a entryway into the assembly language or the machine language, and I like to think that Java is pretty close to that level of things, so that you get, you know, a good amount of control and such. But I'm an assembly language geek, so I like that level of interaction.
It's not that it's bad or anything. It's just like
Mm-hmm.
operator overloading, setters, getters, in terms of like properties.
Yeah. No, there's lots of there's so many different languages, and there's this multi-dimensional space of characteristics and features and styles, and it's great that there's all these different languages for different points in that space. And depending on what you're trying to do, you know, different languages make more sense. Or sometimes, you know, you have a boss who says, well, you got to use Perl, you know, because they were on an airplane flight and they read a story about Perl and they thought, hey, this is going to make our business succeed. And now everybody's writing Perl code, right? Not that this ever happened to me.
Does this language have multiple inheritance? That's my last question.
I believe so, but honestly, I don't do a lot with inheritance, and I don't do a lot with polymorphism and things like that. And so I don't know. I would have to dig into it to answer that definitively. But I believe it does. But yeah, not totally sure.
C# illegalized that as a feature.
Yeah. This happens with languages. All right, so
It's funny how not having something is a feature. You know?
oh yeah, totally. Well, it's like decaf coffee sometimes costs more, you know. And high octane gas is less explosive than low octane. But it costs more. It's harder to make it not blow up. All right, so yeah, use dot equals when you want to compare objects in general. integers, booleans with a lowercase b, doubles with a lowercase d, all these primitives you can use double equal. Alright, so we're ready to tackle statics. I was planning not to get into this for a while, but I think we're at a point where we can talk about statics without getting into too much trouble. But we'll see. So when we have a class like class, I don't know, list. Let's go with rectangle. So we have our rectangle class, and we have an area method. Well, we have, you know, an integer h and w, and we have a area method. And the area method doesn't take any arguments, but it returns the area of the rectangle. And then in my main program, or some other calling program, if I say rectangle r, and I construct it in some way, and I want to know the area of this rectangle, I say r.area. Alright, when we're doing objects, one of the main ideas is we don't pass the arguments to area. The arguments come from this object r, in some sense. Right, we say r.area. Well, r is an object of type rectangle, and inside that object there are these parameters that represent the height and the width of the rectangle, these properties. And so the area method can use those and return their product. And the first thing to note is that if I just tried to call area without referring to some object, that really wouldn't make sense. Right? Running this code by itself without a particular rectangle involved. Hey, audio, excellent. Running this area method without a particular rectangle makes no sense. Because if I just say, you know, tell me the value of this method, well, what is it going to use for the height and the width? Right? Height and the width are fields inside the rectangle class, but if I haven't made a rectangle, h and w don't have values. They don't even exist in some sense. So with a class like the rectangle class, calling the area method without reference to an object makes no sense. Okay? That's the first thing to keep in mind. Now, the second thing to keep in mind is suppose I wanted to make a different method called calculate area, which lets me pass x and y to this method and returns their product. And this is like a helper function. Let's say, you know, you're doing something and you're like, oh, I need to calculate the area of a rectangle. I can't remember what the formula was. Isn't there some method somewhere in Java that I could use to calculate the area of a rectangle if I tell it the height and the width, right? Well, hey, here's a method right here. It's part of the rectangle class. It's a handy little, you know, general purpose method that you tell it the dimensions of a rectangle, it returns the area. This function, it would make good sense to be able to just say calculate area, say 5,7, and it gives me back a 35. And for this kind of method, I do not need a particular rectangle, because I'm not asking for the area of, you know, a rectangle that I constructed earlier. I just want to use this chunk of code. I want to run this function, I want to give it a pair of arguments, and I want to get back the area of the corresponding rectangle. And so in this case, I would very much like to be able to say calculate area without having to have an actual object. And so there's a mechanism for doing that, and it's called a static. And here's the deal. If I put in front of this method the keyword static, and then in front of this call I put in not the name of an object, but the actual name of the class itself, that is legal. And what's going to happen now is that when I say uppercase rectangle.calculate area, it's going to look in this class for a method with this signature and the keyword static. And if it finds it, it'll just go ahead and execute this code. It'll pass those arguments to it, and in this case it would return the area 35. Should have made it 51. So sometimes you create a class. You can think of a class as partially a package of functions, right? And sometimes you create this package of functions and it has functions that make sense even if you don't have a particular object in mind. They're just useful functions. And so you can put a static keyword in front of those methods, and then you can access them using the name of the class itself.
I've been told this is generally bad practice, though. Statics mixed in with an instantiatable class.
That could be. So certainly if you look in the Java documentation, you'll find these things broken out into different classes sometimes. But I would say when you're writing code for yourself, do what makes sense. And try not to get into lots of bad habits. So don't make your methods, start with uppercase letters and things like that, because those are just habits. But I don't know. I rarely encounter statics in my daily life. But I don't know if that's considered best practice. I could see an argument for that.
In this instance, I would use something like an inline or a lambda for this.
Well, this is a very simple function, right?
Right.
But if you imagine this is something much more complex, then it might make sense to make a callable method.
If it was like that, I feel like I would have a static class for that, full of other related functions.
Yeah, and you can definitely do that.
Yeah.
And then it's always function bundle dot whatever. So you'll see terminology for these things. These are sometimes called instance methods and class methods. So an instance method is a method that you run using an instance of a class, right? In other words, an object. A class method is a method that you invoke using the name of the class itself. So this is a class method. And this is an instance method. Class methods are static. And this works not just for methods but also for fields. So I could have a static int some magic variable which is equal to 1.414. And this is the diagonal of a 1x1 rectangle, which is a very magic property. And so if I have a rectangle R and I want to access the height, I could say r.h and grab this field, assuming I'm not using a getter. But if I wanted to access
flashbacks.
Yeah?
B15 flashbacks.
Ah, yes. Getting pushed off the boat. So if I want to access this magic number, right, in some versions of the compiler, I could actually say, r.magic, and I'll get a warning about accessing a static from a non-static context. But the way to actually access this would be the name of the class, rectangle.magic. And so this is an instance variable, and this is a class variable or property. And so if we look at the math class, for example, it's got a bunch of methods inside. For example, for computing absolute value of a number, and the method is defined to be static. So what does abs do? It takes a double, it returns a double, but it's a static method. And so if I have a double and I want to calculate its absolute value, I can do something like y equals math dot absolute x. And that says, hey, go into the math class, look for this method, pass this to the argument, take the return value, store it in x. And if this was instead just a plain old method written inside the class called math, I would have to construct an object of type math and then say object name dot absolute. And that's just kind of silly. All right, and there's some static fields. So there's a field called pi. It's listed as static. It's a double, and it's equal to the value of pi. So that's like our magic number in the rectangle class. So anywhere that I say math.pi, I've got an access to pi, and e is in there also.
Can I ask a question about final, or is that skipping too far ahead?
You can ask. I don't know if I can answer it.
I've noticed, like, with objects themselves, you can't really make them constant. So there's something like a read-only property or the final property here. Why is that? I've never understood why.
So, for example, you can make a string final, and you can give it a value in the declaration of it, and then you basically can't change it. And I think that works with statics because it avoids the possibility that two different objects might have different values of this field. But it's another one of these things that, honestly, I've never had to use. If you're writing code for yourself, a lot of what you can do with modern languages like Java don't really come into play. But if you're working where there's a lot of code reuse and pieces of projects being put together and so on, then a lot of these things like, protected private public and finals and things like that become more critical.
I find that I do have to use things like read-only and final sometimes.
Yeah.
When it's like I just want to have an object for reference and I don't ever want it to change.
Right. But I mean, you could also just not change it, right?
I like to play it safe.
Yeah. So the double class, right? Uppercase double, which is the class version of a double precision floating point. So this has a number of static fields. For example, positive infinity, right? And if you go back to 250, 270, or if you haven't taken those yet, when you get there, we talk about IEEE 754 floating point. And it's a 32 or 64-bit representation of floating point numbers. And there are a bunch of reserved bit patterns in there. And some of those bit patterns represent things like positive infinity, negative infinity, or not a number. And so those are bona fide values that you can give to a double in Java. And you can access those as, static fields inside the double class. So if I say uppercase D double dot positive infinity, that's equal to positive infinity.
Is it like just a bunch of zeros, or?
The bit pattern I don't remember. So there's a normalization that takes place, and I think the bit pattern that would represent the largest positive number or the smallest positive number is treated specially, and it represents infinity. So you lose like one tiny little epsilon of range. And then not a number, I believe, is one of the denormalized representations of zero. Because if you have a zero, you can't write it as something non-zero times a power of 2. So there's a special representation for 0.
I bet with the integer class or like the actual double classes that inherit object, there is some kind of flag on them that you can toggle for infinity, and it just says 0 instead of losing that range you would on primitives, right?
Yeah, except that IEEE 754 was made, when probably Fortran was still being used, and you wanted to be able to store this information about these special values inside that 64-bit or 32-bit pattern itself. So they just sacrifice a few particular values to represent that. And I don't know what the implementation of the double class does. Again, information hiding, we're not necessarily supposed to know, but you could, go into the code and find that out. But I would guess it probably just uses the standard bit patterns for this, but it would be interesting to look at. So double is a class that comes with, some static methods like compare, and compare takes 2 doubles, tells you if they're equal. Well, that's a useful method to run, without having a double object. Square root is a useful method to run without having a double object in the math class. And so there's some static methods like compare or parse double, which takes a string. And then there's some non-static methods like long value, which takes a double and returns it as a long integer. So you need to go into the documentation when you're looking for a method to do something, or when you're trying to understand what a method does. And in here it'll tell you, is it static or not? What type of thing does it return? What type of arguments does it take? And here's a good example with different signatures, right? Is nan, so is something not a number? And if I invoke this as an instance method, it will tell me if the thing that I use to invoke it on is a number or not. If I use it as a static method, I can pass it a double and it'll tell me if it's not a number or if it is. So you can... Go ahead.
It just uses double max for infinity.
Okay. Which may be... Yeah, that may be the standard from 754. Because that would just bump your exponent up by 1.
Wikipedia's page on it's really interesting.
I'll bet.
It's got like a bunch of different values that it considers numbers like not a number and quiet not a number.
Ah. So yeah, I'm thinking that maybe the bit pattern where your exponent is all 1s represents infinity. And so they actually blow that whole batch of space. Interesting. Yeah, this is cool stuff, and before this was standardized, every computer kind of did its own thing, and you'd get a magnetic tape of floating point numbers from one machine. You'd load it into another machine, it would come out like gibberish, because the bits were coded in a different format, and so you got to go and figure out how Honeywell is coding their 32-bit floats and convert it to what some other machine is using.
And now all that stuff is consolidated into x86-64 and ARM.
Yeah. Which you wouldn't want to do without a standard, because that's expensive to change. All right, so that's the basic deal with statics, right? And you can create these and use them however makes sense. But again, for most of what we're going to do in this course, you're not going to need to use statics other than public static void main. So PA1A was an anomaly. I gave you a weird problem that really required you to use statics. But in general, you don't need to use them. In general, you're going to be designing classes and then constructing instances of those and using methods and fields inside those objects, and so non-static fields and methods are going to make the most sense. The danger is if you should not be using something as static and you accidentally try to use it in a static way. For example, if I try to do something inside another class from main, I can get a compiler error which says, static reference to non-static method, and you can appear to fix that by changing this other method to be static. But then at some point, that will cause the compiler to complain, and it will compel you to change something else to static. And if you keep doing this without really understanding what a static is, you end up making half of your code static. And then you try to do something, and you cannot do it because these things can't be static and do what you want to do. So you start undoing that, and you start creating more bugs and so on. So if you find yourself starting to randomly make some things static, if you find yourself just kind of randomly putting that keyword in front of things to try to get rid of errors, take a breath and step away from the keyboard and think about what you're trying to do and see if there's something different that you should change, different from what the compiler is telling you is the problem. That's just kind of a cautionary tale. And yeah, they're good for some quick and dirties. Those quick and dirties can bite you, though. I was at a talk with Vince Cerf a few years ago. He was one of the architects of TCP/IP and the internet. And there was a raging debate going on about how long the IP addresses should be. And some people wanted 4 bytes and some people wanted 6. And he claimed that he basically got everybody to agree on 4 with the argument of, let's just get this thing coded and see if it works. And if it works, then we can go back and change it to 6. Right? And you know what happened with that, right? It worked, and it worked really well, and it became worldwide, actually including the space station outside the world, with 4 bytes, and we eventually ran out of address spaces, and we're still trying to switch over to 6.
Yeah.
So sometimes those one-offs can lead to good anecdotes down the road.
It's I find it kind of like in 270 how in order to get around having only
16 bits.
Do the bank switching.
Yeah.
It's like now we do that all the time with IP addresses.
Yeah.
We mostly use IPv4 and we just bank switch all the time.
Right. And we can blame Intel for the segmented memory. I mean, it's not a blame. I don't think there was a better solution at the time. But the reason we get seg faults, that seg is for segmentation, because x86 architectures were one of the popular ones that segmented memory. So your memory had 2 pieces to it, an offset in a bank and the address of a memory bank. And
you can only access 65,535 bytes per bank at a time. I think.
Yep. Yeah. All right. So that's my lowdown on statics. Other questions or comments about that? All right. Let's do a short break. Well, it doesn't have to be short. We can do a 5-minute break. And we come back. I want to work through putting together a linked list package or part of a linked list package, just as a way to kind of play around with defining some classes, thinking about how to put pieces together, and maybe playing with public-private and things like that. So let's take about a 5-minute break and come back, and we'll dig into that. So I'll see you in a few. Hey, this works pretty well on the side.
Yeah, too, because it's not all that wonky.
Yeah. So what was the static question?
Sorry, I shouldn't pass you.
Oh no, that's good. That's good. Does bypass using the constructor?
Because in this
Yeah,
example,
actually.
it was you're putting in your own parameters.
Right, so you
Is
do not
that
need
kind
to
of the
construct.
purpose of it?
Yeah.
Okay.
Yeah,
And
one-
then, is
one-
this correct? Am I understanding? So you can take the same thing and use it either way? Is that for all of them, depending on if you put it here or you do it with an object?
Let's see. Yeah. So for that one, you can do it. You can do it either way.
But that doesn't work for everything?
No,
Okay.
it's only if that's provided. So my cell matrix stuff, right? I needed a truth table compiler, and I didn't know about statics, so I made a method called, ttcomp, and then in the beginning of my code, I just constructed a cell matrix object, and I called it something goofy, and then every time I wanted to compile a truth table, it was like, goofy name.ttcomp, because I didn't know you could do a static, right?
Yeah.
So that was exactly what it was for. But no one taught me Java, so these things happen. I'm wondering if I can convince people to start using mailing lists at Clark.
That would be such a worthy
Because,
thing.
bakery wants to tell people what's on their menu every day. That's great, If you're
Sign-ups.
interested in that, sign up for the mailing list.
Yeah.
Office of Instruction wants to tell you the agenda for every meeting that they're having, That's great. If you're an adjunct who has nothing to do with that, right? Have people who want that information sign up on a mailing list, and they can get it, and then the other people aren't plowing through 100 emails a day.
That's awesome. Are they needing tutorials on how to make that, or
I don't even
GUI,
know if they support
or
it.
yeah, like, are you gonna have to make the thing to do it, or make a tutorial to do it, or
I have no idea, and I'm not actually going to do this because
what? I think it's a great idea.
I'm all talk and no action.
Oh, you are so action.
Um,
Come here. I think it's a great idea.
yeah, I'm sure I'd get in trouble.
You sure?
Yeah.
Or maybe
Somebody
they
would
would.
say, well, you think that your time is more important than other
Maybe they would
people's
put
time.
a laurel wreath
Yeah.
around your head and hold you up over the crowd
Yeah, the kind
with
with
the
thorns
palms.
on it, right?
Oh, I guess that's true. I was all going that direction.
That was an idea.
I like that idea.
If the IT committee ever meets again, I'll bring it up. Maybe
The
be
bunny
like,
was
I have
out
a
there.
friend who had a question. Bunny was out there. We
Yeah.
should carrots off in the day.
Yeah, we should. I'll see if the bunny will eat a carrot I chew off of.
Okay. Yeah, you get to set it up.
I
Yeah.
tell me how to put the drive in though.
Okay. All right, welcome back. I got windows on top of windows. All right, cool. All right, so let's make a MyList class. All right, so here's the deal. PA1B was an attempt to take what you'd already done in 1A and package it into a class, right, or a set of classes to get some experience with constructors and organizing things and so on and so forth. So I want to kind of repeat that experience here with a different example, which is creating a linked list class. And this won't be a full-blown linked list, but it'll be sort of like the initial linked list implementation we did in 222. So, and we know the linked list class from Java, so we've seen a very extensive implementation of linked lists. But we're going to do a simplified one, but the way we use it is going to be similar to how we use, linked list. But let's just stick with strings. So we'll make a linked list of strings. And I'm going to call this MyList. So it's going to look something like MyList. And we can call it whatever we want. Let's just call it data equals new MyList. So we'll construct our linked list like that. And then if we want to add stuff to our list, we can just say the name of the list dot add. And we can put in a string or an object that's a type of string or something that evaluates to a string. And our simplification to this is this going to add to the beginning of the list. So we're not going to try to sort this. We're just going to put stuff in the beginning. And so we could add a bunch of stuff. And then we can have a search function, so we can say if data.find and this will search the list. And then we're going to make one more method, which is data.print, which will display contents.
I'm assuming the find is the method that we're creating, or is that a built-in method in linked list?
We're going to create all of these.
Oh, okay.
Right, so we're going to call it a MyList instead of using a regular linked list. And so we're going to create this like we did in 222. We're going to make a sentinel node. We're going to initialize it to point to null. And when we add something, we'll have the sentinel point to the new node, have the new node point where the sentinel pointed. And for find, we'll start with the thing the sentinel points to. We'll move from node to node until we either find what we're looking for or we run out of nodes. And print, we'll start with the thing after the sentinel and just follow the nodes and print out the data field of each. So this will be, a pretty rudimentary list package with a constructor and 3 methods. And so the code that we're going to have to write for this is effectively code we already wrote last quarter, right? We know, or we knew, how to set temp equal to sentinel next, and well, temp is not equal to null, etc., etc. So this is all about packaging and bundling and organizing and figuring out how we're going to put these pieces into this nice class called MyList. And while we're doing this, we're going to explore things like information hiding and so on. Sorry, go ahead, question?
We're going to give it a generic?
We may eventually. We probably won't get to that today, but this will be a good example when we want to do generics. Because the fact that we're making a list of strings is not going to be super critical to how we write all of this. We're going to have to use the word string a few places. So yeah, we'll make that generic probably next week. All right, so let's just start with some code. So we'll make a list main.java. So this will demonstrate our linked list code. So we'll construct this. Alright, so we'll add some things to our list, and then we'll say if data.find by So we'll call our find method and see if by is in the list, and if it is, we'll tell you it is, otherwise we'll say it's not. And then we'll go ahead and we'll add by, and we'll do that check again. And so we'll confirm that, you know, our find function is working correctly. And then let's print out the list contents by calling the print method. And then we'll call it done. All right, so there's our main class, right? And we should get tons of errors when we try to compile this. Only 2. Okay, that's not bad. All right, so let's make the MyList class. So we got to put it into MyList.java. We begin with, you know, the class declaration, class MyList. And, you know, this is really all we need to make a MyList, but if we try to compile, the methods are missing, right? So we need print, find, and add. So what are the pieces of a linked list? Think back to 222 when we created linked lists in C. What were the pieces? What were the data and the code pieces? Here's the code pieces, right, that we need. But what did we need as far as data for a linked list?
You need the contents of a node and then link to what is it, like the next node?
Okay.
Node,
so we need some kind of node, which has like a data field and then a next field. And our list is going to be a chain of these nodes. What about an empty list? Do we have any data associated with that?
I think it was just a null node, right? Or I guess the sentinel node.
Yeah, we had a sentinel node. So our trick with the sentinel was we always had this one node, and for an empty list it simply pointed to null. Maybe it had a special data value. But this was not part of our linked list per se. This was a handle to the linked list. It was a thing that always existed, and we could look in this field to see what the first node of our linked list was. So inside our MyList class, we need something similar to that. We need a sentinel node. All right. Well, in 222, this was a struct node star. What should it be in our Java implementation? It's going to have to be an object. And what kind of object? Well, something like a node. So we're going to have to make another class called a node. to describe this structure right here. Alright, so I'm going top down here, right? I started off with a main program, and then I said, okay, let's make a MyList class. Well, right now, before I can do anything else, I need to know what a sentinel is. Is that rain? Yeah, it is rain. So let's go ahead and make the node class. So we'll do node.java. And it's going to have two pieces. There's a piece called data, and this is going to be a string. And then what about the next field? What kind of thing should that be?
Node.
That's a node.
Like, I know that it works, but it feels funky that you can reference an object of that class within that class.
That is very strange. And in C, it doesn't look as weird because this would be, you know, a struct node, and this would be a struct node star, right?
Yeah.
And if we actually tried to put a struct node inside here, we'll get a compile error saying, like, I'm really confused. But that's kind of what happens here, right? This is the blueprint for what a node looks like, but this is actually a reference to a node. So there's still these pointers here. We're just hiding them from being explicit. But yeah, it is good to note that that's a little Inception-like. So here's a simplified version of our node class. It's just a data field and a next field. And that's really all we need to be able to say node sentinel. Alright, so let's write some methods. Oh, I sent a :W in chat, sorry. So we need a constructor, right? Well, what should the constructor do? The constructor should create the sentinel node, because this says node is an object of type sentinel. But if I try to say sentinel.next, I'm going to get an error because sentinel hasn't been initialized. So in the constructor, let's do a public MyList. And let's just construct a new node. And let's set the next field equal to null, because that's how we represent an empty list as next points to null. And I'm just going to do something special in here. I'll just put a magic value into the data field. With a note that we should never see this. Right? The sentinel node of a linked list is just a handle to the first data node. So when we're searching, when we're adding, when we're deleting, when we're printing, when we're doing any kind of traversing of the list, we always want to begin with the node the sentinel points to. So if I'm developing my code and somewhere along the way I see the constant dead beef, I know I've stumbled across the sentinel node, and I've probably got a problem with my pointer somewhere. So I'm setting this up to just some peculiar value that I'll recognize if I see it, and that will help me, you know, avoid a few bugs with starting my list traversal too soon or things like that. And it's hailing again. I said 2 o'clock, it's 2:15. Close enough. Alright, so there's the constructor. And maybe I didn't even have to do the setting of these values. You know, I could have done these values in my main program when I construct a MyList, but that breaks the firewall, right? I want my calling program to interact with my list by using MyList, add, find, and print. And if after I construct a MyList I need to say something like data.sentinel.next equals null, Well, now I'm asking the caller to understand and interact with the implementation of a MyList. And so we want this differentiation between the user of a class and the implementation of the class. So it really makes most sense to do these kinds of initializations inside inside the constructor for the list object itself.
Is there any reason why you didn't make like a private inner class for the node?
I don't want to do inner classes right now because I'll probably end up with people putting everything in one file in the end. But since it came up, yeah, so you can actually define another class inside this class, and it's a genuine class on its own. And then you have one file. But if you have a class that's only going to be used in here, you can put the definition of that class inside here, and that's called an inner class. And it compiles to your file name with a $sign and another piece to it, and so on. And it's a convenience. But we'll stick to one file per class for now.
Is there a reason that we didn't make the Sentinel node private?
Because we're going to go back and do that later as an excuse for making accessors and mutators.
Gotcha.
Cool. All right. So there's a constructor. What else do we need? We need an add method. All right. Add methods are fun to write. So let's add a node to the start of the list. So this is public. It's not going to return anything. It's going to be add. And it's going to take in a string. And I don't know what to call the string. I'm running out of variable names. I'm just going to call it S. It's a terrible name. All right. Well, how do we add a string to the start of the linked list? The usual drill is you've got your Sentinel. And it points to some stuff like that. So we get a new node. We create a new node. We put our string S in it. We set this to point wherever the Sentinel is pointing. And then we change the Sentinel to point to our new node. That's how we insert into the beginning of a list. So create a new node. Have new node point where Sentinel points. Have Sentinel point to new node. I never write comments like this. I don't know why I'm doing this. Alright, how do we create a new node? We have to declare it. So I'm going to say this is an object of type node. I'm going to call it new node equals new node paren paren. So there's our new node. New node.data equals S. So we'll set it equal to whatever that argument is. We'll set new node next equal to whatever Sentinel next is. And then we'll set the Sentinel to point to our new node. And we're done. How's that? All right. So the point here, the reason I'm doing it like this is to reinforce this idea that you figure out what you want the computer to do, and then you write a set of statements to tell it to do that. there's no real magic at this stage of things, right? I want a new node. I'm going to make a statement that creates a new node. How do I do that? I say new node. And then I want to point to whatever the sentinel's pointing to. Well, I just set the new node's pointer to be whatever the sentinel's pointer is, and so on. So I want this to seem not too mysterious, right? All right. Let's write the print method. Print method sounds more fun than the find method. So let's print the list contents. So this is a method. It doesn't take any return value. It's called print. It doesn't take any arguments. So how do we print the contents of a linked list? We start with a thing the sentinel points to. So we'll have, something like temp, which is the node the sentinel points to, and as long as this is not null, we'll print its data field. We'll set temp equal to whatever it's pointing to, and if that's not null, we'll print its data field, and we'll continue until temp is the last node. We'll print its data field. We'll set temp equal to whatever this is pointing to, which makes it null, and then we know we're done. So we need a temporary node, so I'm just going to make a object called temp. And I'll set this equal to sentinel.next. Now in C, when we did this and we were passing the sentinel as an argument, we know that C is passed by value. We could use the sentinel as a local variable. And we could monkey with it inside here, and when we exited, no harm was done, because the value that we passed to our C function would not be changed outside of that function. But here, if I were to set sentinel equal to sentinel next, I'm changing this thing. I'm losing the handle to the actual linked list. So I've got to use a temporary variable here. And then it's just the usual, well, temp is not equal to null. And let's just print out temp.data. And we'll print a comma at the end. And let's move down the list. And at the end, we'll just move to a new line. So I'm going to print these out all on one line. So I'm just using print. And so there's our MyList. And so I'm going to get rid of all of this stuff. And I'm just going to test the constructor, the 3 add calls, and I'm going to print out the list contents. And let's see if this works. And this is sort of a minimum that I had to develop to test what I've done so far. Construct, add, and then print. And I want to be testing my code as I'm developing it, right? I never want to write 1,000 lines of code and then compile it for the first time, because your errors can come from anywhere that you've been writing. And if you had a conceptual misunderstanding, you may have reproduced that misunderstanding dozens of different places, and you're going to have to fix all of that. And it's just, you end up debugging your debugging process, right? So you want to develop your code usually in pieces, as much as you can reasonably test it as you're developing it, so that by the time you get to the final version of it, you've made maybe a few changes that you're checking. All right, so let's see how much trouble we can get into. Oh, my data is a string. Okay, my bad. I was thinking integers. All right, so there's a different particular value for the Sentinel node. All right, so we've got node.class, MyList.class, listMain.class. Let's see what it does. All right, it said, but fun, this is weird, hello. And that's actually the correct thing to do, because we added hello, this is weird but fun, and we're inserting in the beginning of the list, right? So the last thing that we added, but fun, should be in the beginning of the list, right? This is a stack, right? This is how you wrote a stack in PA2 last quarter, and how you did a stack, in PA1 this quarter. You just use a linked list and you insert in the beginning. So last thing inserted is the first thing in the stack. So this seems to be working, right? But fun, this is weird, hello. All right, what if we wanted to add to the end of the list? Is that much more difficult?
You'd want to go through from the Sentinel node through until you get a null reference, right?
Yeah.
Next, and then add there.
That's
you
it.
also have the liberty here to since you have encapsulation, to make a end sentinel also.
This is true.
So that way you can have like an O1 operation when you go to add the end. instead of
Awesome.
Walking the entire list from the beginning as well.
So what he's suggesting is, in addition to having a sentinel at the beginning of the list, we could have an end sentinel that always points to the last node of the list. And now if we want to add to the end, instead of starting here and moving through till we get to the end, we could just say, end sentinel next equals new node. And then change end sentinel to point to that new node. And now we've got, a pair of pointers that get us to both ends of the list in order 1. And that's hard to do in C, because we would need the person who calls the program to pass not only a sentinel but also an end sentinel. But in a class, we can put that in as part of the class, and it's oblivious to the user. The user is oblivious to it, right? It's invisible to them that this is how we're adding to the end of the list. So let's do this. Let's do it the old-fashioned way. So let's set temp equal to sentinel. And while temp next is not equal to null, temp equals temp.next. So now temp is the last node in the list. So we'll make our new node. New node.data equals s. New node.next equals null. And then temp.next, which we've discovered is null, is going to point to new node instead. So down here where we say add, we'll change that to add to end.
You can also have them for the length too. I think that's one of the coolest things about object-oriented programming. It's not just the data you have in the classes, but it's also the state you have in the classes.
Yes, yes. So let's go ahead and embellish our add to end method to use an end sentinel. And because right now this is an order n operation, right? To add to the end, we need to do this loop that goes through all n nodes in the list. So this is a pointer to the last node in the list. So when we construct, we'll set end equal to the sentinel. Because if we have, nothing in the list, the sentinel is pointing to null, end should also point to null. And basically when we want to add a new node, we're going to add it after end. So let's make an add to end fast. So we'll create a new node. We'll set the data field equal to S. We'll set the next field equal to null. And now we're going to say end.next equals new node. So we'll change the last node to point to this new node. And we'll adjust the thing that's referring to the end of the list, which we call end. We'll adjust that to point to new node. And here we go. We're still working. We're adding things in, first out order now. But we got rid of the loop. Oh, I didn't change my main program. There we go. So we're adding to the end of the list still, but add to end fast. There's no loop in here. It's order 1. And the only reason we're able to do that is because this is an object, and part of that object includes not only the sentinel node, but the pointer to the end. And we can do a lot of stuff with this. So as somebody else mentioned, we could store the size of the list in an integer. We could initialize it to 0. Every time you add, we increment. When you delete, we decrement. And then if somebody wants to know how many things are in the list, instead of looping through and counting, we just return the value of that integer. And doing an add takes one additional operation to increment. Doing a delete takes one operation to decrement. And asking how big the list is takes a single operation, just return the value of that int. And so we could have another class, another variable inside the class declaration called, size of list. And you can do all kinds of things like this. This would work great for a queue. Remember when we did a queue with a linked list, we needed access to the beginning and the end. And if you wanted to not have to traverse the list to get to the end, we had a tail pointer. And there was this question of where do we keep that tail pointer? Where do we store that? And you could make it global, but then you've got a global and you can only have one queue and so on and so forth. Well, we could put a tail pointer in here. That's basically what we just did. And so we've just created a queue. If we had a remove from the beginning function, we've got our queue package.
It's also like, you could do this in C where you could have some sort of structure to store the data and some structure to have the state of the data, but they're both here in this one class at the same time.
Right.
So you only need to instantiate one thing, and there's true encapsulation. So
Right.
that you could have, like for say the link, it could be publicly readable, but there's no mutator or a setter on it, so
Right.
it doesn't break the structure at large.
Yeah. I thought you said you didn't use the word instantiate.
I I use it when I'm instantiating a class.
Okay.
I don't call the constructor instantiator.
Okay, right.
I understand what you do, though.
Yeah. All right. So is this making some sense to people? Right. This is just packaging stuff up that we've already written before, but it's putting it into this kind of, well, encapsulation is the term, but this kind of unified structure where there's data associated with our data structure, and there's also code or functions or methods associated with our data structure that manipulate that data or use that data. And it's all bundled together. And to use this, we just say make a new MyList, or call the add to end fast, or call the print method. And all of those details, the fact that we have an end method, I mean, I could just call this add, right? And have the add method do this funny business of keeping the end pointer and so on and so forth. I changed the name of it so that I could keep the old code in here, because I'll post this code for future reference. All right, so let's do our find function, and find is probably a bit of a not as exciting now that we've done all this other stuff. But let's search the list. So this is a public Boolean find, takes a string argument. And this will return true if the string is found in the list. So, usual drill, right? Start off with the thing the sentinel points to. And as long as that's not null, then temp is pointing to an actual data node. So if temp.data equals s, return true. And this means that we found the thing we were looking for. If we get all the way through our list to the point where our temp node is null, we did not find what we were looking for, so we can return false at that point. So there's our find method.
Are there keywords in this language like ref and out? So when you, let's say, you want to have that return a Boolean, but if you actually do find the node, you want it to be like an out parameter that returns the actual node in the list if you find it?
You mean as a function value, or as like a parameter that you pass in the argument list?
Like a parameter you pass that can be an out parameter that returns the node that you found if you do find it,
So these things are called by value. Just like in C, arguments are passed by value. But could you pass the value of a structure that points to something? I don't know. It's a good question.
In C# there's a few keywords like ref,
Mm-hmm.
and a couple others that are like different levels of
Reference.
different levels of filled out
Mm-hmm.
object that you can return as an out parameter.
Right. It's a good question. I wonder if there's a type of class I could create that I could pass and have a field in that refer to a node that I could modify and then get to the changed value, kind of like passing the address in C. I'm not sure. I've always just used return values and passed back objects. All right, so let's see if this works. Oh, I didn't expect that. That can't be good. That feels like I forgot to move down my list in my find method.
Oh yeah.
I think that cost me like 5 points on the exam. All right, so if the current node equals the thing we're looking for, we can return true. Otherwise, Move to the next node. Did I actually just do that? Okay. I have to go back and delete that from the video. Alright, Java list main, there we go. By is not in the list, and then we added by, and by is in the list. And now the list contents by. Hello, this is fun. This is weird, but fun. And by is in the beginning because I didn't change that, so I just used the plain old add that adds it to the beginning. So this all works. Again, the goal here is not so much the code itself as it is the organization, as it is kind of the mindset involved in organizing our code this way to play nicely as a class. I did not mean to record that. There we go, chat window. And there is no refn out in this language. Okay. All right. Let's make one more embellishment. Let's get rid of this print method, because print is great if you want to send a display of your list contents to standard out, but you may want to do something different with it. You may want to add something to the end of it. You may want to save it in a file or whatever. So let's make a toString method for our list that lets us just take our object and concatenate it to a string and have it print out the contents. So if I run my list main right now, it tells me list contents, and it gives me, you know, that internal representation of this object, the type of object, and then some sort of memory reference. So we need to do some work to be able to turn this thing into a string. So how do we do this? It's got to be public. It's got to return a string. It's got to be called toString. It takes no argument. And we're just going to kind of grab the code that we had up here. So we'll start off with the thing that the sentinel is pointing to, and while it's not null, instead of printing it to standard out, we're going to concatenate this to a string that we're going to build up. So let's make a temporary string. I'm going to call it return string. I'm going to initialize it to be quote quote, and this is what we're going to return at the very end. So in here, instead of printing temp.data, I'm going to say return string equals return string plus temp.data plus a comma. And then I'll move to the next node, and then at the very end, instead of printing out a new line, I'll just return string. And that should be enough to let us do this kind of thing. Take our object name and concatenate it to a string and have this method called, and what will be concatenated will be the value of return string, which should be this nice comma separated list of strings. So now if I run this, it says list contents, and there's our list of strings. If I want to put my strings in quotation marks, I can append a quotation mark in the beginning. So I'm going to append a \quote and then temp.data and then I'll put inside double quotes a backslash quote to put my quotation mark at the end. And now list contents, and it shows me bye, hello, this is weird but fun. Alright, we're on a roll now. Let's just keep going. Let's get rid of this annoying comma at the end. Because this is always a minor irritation, right? When you do this kind of thing, there's always this extra comma at the end or an extra comma in the beginning. Right? So I can get rid of the comma at the end. And I can put it in the beginning instead. So now, you know, the end looks great. It ends with but fun. But I've got this comma in the beginning here. So how do I get rid of that leading comma? What's the sort of plain spoken way to do that? Forget about code. If you give somebody a list of strings and say, hey, write these on the board for me with commas in between them, but don't put a comma in the beginning, right? What's the logic you have to follow to make that happen?
I'll check if the first value, or yeah, basically just check to see if it's the first value, and if it isn't, then put a comma before it.
Yeah, check to see if it's the first value, and if it isn't, put the comma before it. Alright, so how do we do that in code? Let's use a flag. I'm going to set a flag equal to first value. And when it's true, it means we're printing the first value from the list. So in here, I'm going to say, if not first value, I'm going to stick a comma at the end of our return string. And then I'll go ahead and concatenate the return string plus the data field from this node. And then I'll clear that string to say, hey, we're not at the first value anymore. Alright, so this is a flag. I set it equal to true, and the first time through, not first value will be false, so I won't concatenate a comma. I'll clear that flag. The next time through, not first value will be true, so I'll concatenate a comma, and I should get all of these commas except that first one. And so there you go, you've gotten rid of the annoying comma. All right, questions? All right, what else can we do to this to support kind of an object-oriented mindset? Our main class looks pretty clean right now, right? We're constructing this data object of type MyList. We're calling different methods and using it. I got no problems with any of that. Let's take a look at MyList. And in MyList, we're using these fields called node. Ideally, we would like these sentinels to be private. The sentinel and the end pointer, let's make those private. Now, we're not trying to manipulate those from here, but theoretically we could. As soon as we have this list called data, I could say something like, you know, data.sentinel.next equals. And I could come in and I could start playing around with my list. And I could do things that end up breaking the MyList package. For example, if I decided to delete the last node manually, if I just started with, data.sentinel.next, and I moved down until I got to the second node from the end, and I changed that to point to null, but I did not also change the value of end, I've broken my MyList package. And maybe, when I first had this MyList package, there was no end pointer, and now there is an end pointer. Well, my code's not going to work anymore unless I change it, right? And so part of the idea of making these things private is, hey, the only way the person is going to interact with this is through these public methods, right? Or maybe some public fields if I have public fields. And the other fields that are private, those are inaccessible from outside. And so if I compile this, this should still work fine. But we can extend this mentality. And notice down here when we construct a node, I'm saying, that node.next, that node.data. And what I'm doing is, from MyList, I'm coming in and I'm interacting with these fields of a node. And maybe I don't want to have that happen, so maybe I should make these private also. Well, if I do that, and I recompile it, right, I start getting error messages. So we got an error message here saying tried to access field node.next from class MyList, illegal access error. Alright, we can look at the stack list here. This is line 6 of listmain.java. So line 6 is right here where I call the constructor for MyList. And MyList line 9 in MyList.java is where we tried to access the next field of Sentinel, and it's saying illegal access. And if I try to recompile MyList.java, it'll actually tell me that I have these attempts to go into private fields, right? Next is a private, and I'm trying to modify it from outside of the node class. So how do I allow myself to do things like this? Well, one way is to set up these fields in the constructor. And so I could make a constructor that takes a pair of arguments. The first representing the data field for the newly constructed node, the second representing the next field for the newly constructed node. And so now I don't need to say .next equals .data equals. And same thing down here. I want to construct a node. I want its data equal to S. I want its next field equal to sentinel.next. I can do both of those in the constructor. And then I'm going to have to say sentinel.next equals new node. Well, how can I do this? Sentinel already exists. How can I get to its next field? This is where I can use accessors and mutators. So we got to add a few things to here. Because it's still not going to compile. We got rid of 2 errors. Alright, so I'm going to construct with 2 arguments, a string called D and a node called N. I'm going to set data equal to D. I'm going to set next equal to n. There's my constructor. Still at 21 errors. So let's just allow access to the next field from outside this class. So an accessor, public string, get next. Sorry, data. All right, so the get next method just returns next, which is a node. And then the set next method sets next equal to the argument. And so down here where we used to say sentinel.next equals null, we're going to call a method and call sentinel.setNext new node, not null. And now we don't need access to this private field. We call a method, and the setNext method has access to this private field because it's in the same class. All right, let's do our countdown to success. Down to 20 errors. So add to end fast. We could create a new node. Well, we want the data to be equal to s, and we want next to be equal to null. So let's just put those as arguments to the constructor. So s comma null. And then again, we want to set end.next equals new node. So we're going to say end.setNext new node. And then add to end is going to be the same thing. And then to change the next field of temp, we're going to do temp.setNext new node. So one thing you're seeing right here is the importance of defining and describing and documenting your classes sooner rather than later. Because if you get a few thousand lines into a project and at that point decide you need to do what we're doing here, which is make some of your fields private, you got a lot of editing to do, and your error count comes down very slowly. And so two things to expect. One is, spend some time figuring out what you want your classes to look like, designing them before you start coding them. And the second thing is sometimes a project grows to a point where you really need to kind of start over. You began with, a set of classes with certain specifications, and as the project grew and the way you use those classes maybe evolved, and the classes themselves began to change, you may suddenly realize, like, oh, this thing should actually be 5 different classes. Or these 3 different classes should actually be one single class. And you may see opportunities for some gross restructuring that's going to make a lot of sense. And so you may at some point want to kind of go back to the drawing board, redescribe your classes, and sort of start over. And that happens, and that's not a bad thing. All right, so we'll set temp equal to sentinel.getNext. We'll have to do temp.getData. So data is going to be private, so we'll need an accessor for that. And then temp equals temp.getNext. We talked about this in yesterday's class, and we didn't actually do it because it felt like it was going to be a lot of work. I think that was a good instinct. Alright, so there's getNext. Let's get the data accessor here also. Alright, getNext will not, if temp.data equals, alright, so this is going to look pretty cool. I'm going to do temp.getData dot equals. We'll put that on its own line. Alright, temp.getData that's an object. Yeah, I'm calling a method, but that method returns a string, which means this highlighted thing right here is a string, which means it's an object of type string, and the class string contains an equals method. So temp.getData dot equals is the name of a method in the string class, and I'm passing an argument of s. And the return value from that equals method is a Boolean. And so this whole thing is, if this Boolean expression is true, then return true. And this business of stringing together, you know, an object with a method, with another object, and so on and so forth is pretty typical in Java. And it's kind of an analog to when we had, you know, arrows pointing to arrows, temp, arrow, next, arrow, left, arrow, right, arrow, data. It's the same idea here. Alright, toString is our last method. Let's fix this up and see if we can make it work in the next 7 minutes. Temp equals sentinel.getNext. Temp.getData. And then temp equals temp.getNext. And return string. Did we jump from 12 errors down to 0? Pretty close. Alright, line 18, I'm doing a sentinel.next. So this should be sentinel.getNext. And then line 46, I'm doing temp.next a couple of times. So, well, temp.getNext is not equal to null. Temp equals temp.getNext. Sometimes you fix the last error on a long string of errors that you've been whittling down, and you get to the last 3 errors, say, and you fix those, and then when you compile you get like 117 errors suddenly, because the compiler can only do so much compilation if there's syntax errors. And sometimes there's a whole batch of other errors, but it hasn't gotten to that part of your code yet because you couldn't get past some of the earlier steps. And so sometimes, you know, you get your error count down to 3, 2, 1, 0, and all of a sudden there's a whole new batch, right? Those are good things, yeah. It's a sign that you are making serious progress, right? And if you have, you know, 117 errors in a file that's only, you know, 97 lines long, it's probably something pretty silly, like maybe you know, your keyword class was misspelled and it doesn't know that anything in this file is part of a class or something like that. So just keep chipping away, right? And it will get there.
You gotta pay attention to those warnings too.
Yeah, and pay attention to the warnings. All right, let's see if list main still works. It looks like it still works. It's amazing. By is not in the list, by is in the list, and then it added it to the beginning, it added the other things to the end. All right, so that was a long drawn out exercise in creating, you know, a linked list class, taking the things we've written before, putting those into kind of the framework of object-oriented design, and then going ahead and doing the things we need to do to do information hiding, right? To make sure we can't access these directly. Now this was a little bit silly, right? I made these things private. I made string private, but I made next private, but I gave you a way to read it and to write it. And the setter does nothing other than take your argument and set next equal to that, right? So that's a little bit silly. But the data field, I did not give you a mutator, right? I can set up the data field when I construct the node, but you can get the data field by saying get data, but I did not give you a set data method. And so why would I do that? Well, maybe when you add a node, I throw it into a hash table, right? And if I let you come in and manipulate the data field in a node, right, that might perturb my hash table. And so maybe I'm hashing all of the data that you add to your linked list so that when you try to search for something, I can do a quick hash table lookup instead of traversing the list. So you can control exactly what access you want to grant and if you want to put limitations on it. Maybe I don't want you to be able to have two nodes with the same string in them. And I could control that, you know, in my add method, or I could control it in the node method. Let's see, question, all of this will be applied for PA2. Some of this will be applied for PA2. I haven't quite figured out what PA2 is going to be, but I think it's going to be something that involves putting multiple data structures together. And so I'm hoping to keep pushing this idea of thinking of classes as things that, you know, use and manipulate objects made from other classes. So the MyList is really a bunch of stuff related to nodes, right? And then the main program, list main, was really just a bunch of stuff related to MyList. And the main program right? There's nothing in here that ever talks about a node. The class node, N-O-D-E, never appears in here. And that's deliberate, right? If you're working with a linked list, you don't really care about nodes. In fact, when you work with the linked list class from Java, we don't actually know if there's any nodes or not. It could be implementing that whole linked list with just a big long array. And it could just be pretending that it's a linked list, right? And we would never know that unless we, did some speed analysis or something. So we really don't want to require that a program at this level interact with nodes, and more importantly, we probably don't want to allow that. So we have very controlled ways that this main program can interact with a MyList.
This is why I was so excited to learn about red blacks last semester, because I've been told that most of the collection structures in C# have been implemented in red black in some way or another.
Ah, yes. Yeah, and I don't know what it is in Java. I don't know what they use underneath. I like to think it's purple and sparkly, whatever it is. All right. That's going to do us for this week. So finish up TA1B and submit that as a tar file if you haven't done so already. I've got about half of the submissions so far from this section. Only one submission from the Monday-Wednesday section, which is interesting. But go ahead and finish that up. Get it submitted by tomorrow at 8. Get your ODP done by tomorrow at 8. Come by office hours 7:30 to 8:30 if you have questions tomorrow. And otherwise, have a great day, rest of the week, weekend, and I will see you on Tuesday.
Good one.
All right, thanks.
Thanks.
Thanks. Have a fantastic day.
Thank you, you too.